Inductors. Inductors are the third passive component used in electronic circuits. It stores energy in the form of magnetic field and delivers it as spent when required. Whenever the current passes through the conductor, the lines of magnetic flux are generated around it. Then this magnetic flux opposes any charge, any change in current due to induced EMF. This opposition to the change in current is known as inductance, and the component producing inductance is known as inductor. The unit of inductance is Henry. This induced EMF is actually given by E is equal to minus L into di by dt, where E is the induced EMF in volt at any instance. L is the inductance in Henry, and di by dt is equal to rate of change of current. The negative sign in the above equation indicates that the induced EMF opposes the cause for change in current. An inductor is usually a coil of copper wire wound around a core made up of a ferromagnetic material. The inductance of the coil L is given by L is equal to mu naught mu an square divided by L Henry, where mu naught is the permeability of the free space. Its value is given by 4 pi into 10 power minus 7 h per m is equal to 1.257 into 10 power minus 6 h per m. Mu r is the relative permeability of the core material. A is the area of the cross section of the core. N is the number of turns of the coil. L is the length of the core. Hence, the value of inductor depend upon the following factor: number of turn, permeability of the core material, and size of the core. Inductor can be divided into two categories: fixed inductor and variable inductor. Fixed type of inductor can be divided into three categories depending on the type of core used. They are air core inductor, iron core inductor, and ferrite core inductor. Air core inductor in radio frequency application where very low value and inductance is required, air core inductor are generally used. Air core inductor consists of a few turn of coil wire wound in a hollow former. Iron core inductor, they have a coil containing a number of turns of copper wire wound on a hollow former, and the core material passes through the former in such a way that it forms a closed magnetic path for the magnetic flux. The former is made up of paper or plastic material. The core is generally made up of silicon steel in the form of thin laminated sheets. Laminated sheets are used instead of solid mass to reduce the hysteresis and eddy current losses. Iron core transformers are used in low frequency applications such as filter circuits in low power supplies, chokes in fluorescent tubes, as a reactive element in AC circuits. The value of inductors are generally in the order of few henries. Ferrite core inductors, iron core conductors are not suitable for high frequency application. This difficulty is overcome by the use of ferrite material as the core. A ferrite is basically an insulator having very high permeability. Ferrite is made up of non-metallic compounds consisting mainly of ferric oxide in combination with one or two bivalent metal oxides. They are hard, dense ceramics, and because of their high resistivity, they can be used in the form of solid force. The value of such inductor is in the range of few microhenry to few millihenry. The typical applications of ferric core inductors are in RF chokes for supply decoupling purposes, switching regulator type DC power supplies, and various type of filters used in communication equipment. Variable inductors in certain applications such as tuned circuits, it is required to vary the inductance from a minimum value to maximum value. The ferrite core variable inductors are generally used for its purpose. In such inductors, The hollow former on which the coil is wound has screw threads. The inner hollow portion, similar matching threads are provided on the ferrite core, which can be screwed in or out of the former because of the change of position of the ferrite core. The value of inductance will be changes. It is maximum when the ferrite core is fully in. The variable ferrite core inductor is shown in the figure 2.27. The variable inductors. Ferrite core inductor. The variable ferrite core inductor is very much less when but increases in transformers with iron power and ferrite cores. And air core coils have the values of K will be 0.05 to 0.3. Connecting inductors. Inductors in series. The combined inductance of any two coils connected in series aiding having self-inductances of L1 and L2 respectively will be given by L is equal to L1 plus L2 plus 2M. But if the coils are connected in series opposing, their combined inductance will be L is equal to L1 plus L2 minus 2M. Inductors in parallel. If the two coils are connected in parallel with the fields aiding, then 1 by L is equal to 1 by L1 plus M plus 1 divided by L2 plus M. And for two coils in parallel with the field opposing, then 1 by L is equal to 1 by L1 minus M plus 1 by L2 minus M. Thank you.